So this is the guided notes section 1.2, and we're talking about characteristics of functions. And basically a function is increasing on an interval if f of x sub 1 is less than f of x sub 2, when x sub 1 is less than x sub 2, for any x values x1 and x sub 2 from the interval. So what that means in plain English, that's all technical math jargon. Not that that's not important, but what's more important is you understand what's happening. Basically, a function is increasing if from left to right over an interval, it's rising. So in this graph below, right, from here to here, right, this interval is between, that's 0 and 2, between 0 and 2, and I'm including 0, right, and 2, these x values. Between those x values, the function is rising from left to right. So that's an example of increasing. A function is decreasing on an interval if, I'm not even going to read that whole mess. It's the same math jargon, just basically the other direction. And an example of a decreasing function on an interval, well, here's an interval, right, between 6 and 8, right, between 6 and 8, that's an interval. And at this interval, the function is falling from left to right over the interval. So this is decreasing. Let me, if I can, this is decreasing over the interval, and this is increasing over the interval. So here we go. The given function is from 2 to 4. Now let's see, between 2 and 4, right, we're talking from here to here. From 2 to 4 is the graph rising or falling? I'd have to say it's falling, right? So that means this function is decreasing over this interval, right? And here's your interval, right? This is right from the stuff we worked on last section, and that's why knowing intervals was important, so we could, communicate about these graphs, and we'll know what we're talking about with each other. So the given function is increasing or decreasing on the interval between 4 and 6. Well, let's see. 4 and 6 is here and here. Right? Is the graph rising or falling between those two red lines? Definitely rising. So the given function is increasing over that interval. So as you can see, we have a lot of different ups and downs in this graph, right? Here's increasing, decreasing, increasing, decreasing, increasing, decreasing. So I hope that helps illustrate that this is not a complicated topic. Just as often is the case in math, sometimes complicated language is used to describe simple relationships, and that's the case here. This is an easy concept, right? The graph's going up or the graph's going down. So I'm going to move on to the next section of the guided notes. The average rate of change of a function is the ratio of change. The ratio of the change in the function when you take f of x sub 2 and f of x sub 1 and subtract them, or between the two. So in our previous example, right, we had a graph that was going up between the interval of 0 and 2. The average rate of change would essentially be the change in the x values. And we're gonna break that down in just a moment. So I'm just drawing the graph that you have on the page in front of you. So you can see it on this screen a little bit, but right between 2 and 0, this is what the function looked like, right? And so basically, if we're trying to find the average rate of change over the interval from 1 to 2, right? We're talking about from here to here is the interval. We're talking about, it went up 1, so it's 1 minus 0, and between 2 and 1, 2 minus 1. So the rate of change, and you might have remembered this from last year, is also known as the slope of the line over the interval. So another concept is concept of maximum values and minimum values. In our graph, right, we had a bunch of peaks and valleys, right? All the peaks are maximums. The valleys are minimums. So the maximum value is the point where the function changes from increasing to decreasing. And a minimum is the point where a function changes from decreasing to increasing. So give you a moment, and then we're going to take a look at some theoretical real-world examples. So take a moment to read this problem over. So let's see. They start off with a certain amount, right? They start off with 100 cartons of strawberries. Now, for the first 3 hours, they sell 20 cartons per hour. So after 3 hours, 3 times 20 is 60. So 100 minus 60 is going to be 40. So basically, here's our graph so far. 3 hours, 20 cartons an hour. After the third hour, we're down to 40 cartons. Then for 2 hours, we don't sell any cartons. So the graph will stay flat. You're not gaining or losing. Then you spend another 2 hours stocking 10 cartons an hour. So here's 10 over 2 hours. And then finally, the last hour, they sell 30 cartons. So between hours 7 and 8, 60 minus 30 is 30. So here's our graph with a whole bunch of peaks and valleys. So let's see. Where is the graph decreasing? Right? So from left to right, where is the graph rising? Over what interval? So the graph is decreasing, right, on the interval between 140. And where's the graph increasing? Is that the only place the graph's decreasing? No, it's also decreasing. It looks like over the interval. You know what? And I wrote this wrong. It's not 140. It's actually intervals of time, right? Between our 0 and 3. And it's also decreasing over our 7 and 8. Now the graph is increasing, right, between hours 5 and 7. And what are some maximum values on the graph? Well, we started off with 100. But to be a maximum, it has to go from increasing to decreasing. So 100 really wouldn't be our maximum. I would say the maximum here, right, is at 60. And what else would there? That occurs actually at the point 760. If we were graphing this. And what are the minimum values? It looks like 30. 30 is the minimum value, or the 0.830. Now these are signify points, right? These are not intervals. So now let's think about this graph here. Let's describe its end behavior. So as x approaches, let's see, positive infinity in hours, what happens to the value of f of x? It looks like it's going down, right? Could you ever have less than 0 cartons though? The answer is no, right? You can't have negative 10 cartons of strawberries, so we're going to say it approaches 0. So that describes the end behavior. And I'll give you a moment. We'll move on to the last section of this chapter's notes. Okay, so this last example shows a graph, and it wants you to determine the intervals at which the function is decreasing and increasing, and identify some minimums and maximums of the graph, as well as its domain and range. So as complicated as this sounds, right, well, let's see what are the intervals of decrease. So I'm going to mark those in red. So we are decreasing, it looks like from here to here. So that is between the numbers 3 and 13 over that interval, or you could say 3, 13, or it's not x per se because it's talking about time. Let's go with t. Or you could say, with this funky bracket, t such that 3 less than or equal to t less than or equal to 13. Now you don't have to write all that. I'm just writing it all to show you the 3 different ways we can notate this decreasing function. And that's it. Doesn't look like it's decreasing anywhere else. Right? From basically this whole area, the thing is decreasing. And it's definitely increasing, right, between, I'm doing these in purple, right, it's increasing here, it's increasing there. So what intervals are that? That's between 0 and 3, and 13. And it looks like 18. Or you could write it like this as well. So where are the mins and the maxes? So I'm going to pick another color. I'm going to pick yellow. There's a min, or there's a max I should say, and there's a min. So hopefully these colors, you can see them clearly. Let's see. Right, this is a max. This is a min. So what are the min and max values? So it looks like a max occurs. Yeah, max occurs, and we want to know the value of y that it occurs at. So it occurs at, what is this value here? That looks like 2.5. And a min occurs, what is the y value there at that min? That looks to me like 0.75. The min occurs, I can't spell. Min. Now let's talk about domain and range. Well, domain is definitely limited, right? Domain is all the x values, and it goes from where? From 0 to basically 18. So the domain is here. I'm just writing it as an inequality. And the range, what are the range of the y values? It looks like it doesn't get any lower than 0.75 or any higher than 3. So the range is between 0.75 and 3. There you go. That's section 1.2. We'll move on to the HRW classwork. And there you go.